today's session of quantity surveying, or estimation and costing as we call, we shall study the methodology for the preparation of a detailed estimate of a pipe culvert. As you all know, quantity surveyors are in great demand all over the world. We are next to the booming software industry. So I just suggest all of you all to have strong concepts of the fundamentals. So shall I show you a pipe culvert? Yes, here it is. Herein you can see in the picture a pipe culvert. You can see the road here. There are 3 pipes here which are basically provided to carry the water from one side of the road to the other side. Based upon the volume of water to be handled, we can have a number of pipes. Sometimes we have a single pipe, 2 pipes, 3 or even 4 you can have. This is the road. In order to provide an uninterrupted traffic, this is one method of providing a culvert. The purpose of this culvert is to facilitate safe transportation of water from one side to the other. Here is the other picture. You can see 4 pipes running through here. This is a slightly bigger pipe culvert, and here 4 pipes are provided to carry water from one side of the embankment to the other side. And now shall we define a pipe culvert? Yes, here it is. Now what is a pipe culvert? A pipe culvert is a short pipe used to carry water through a highway, embankment or a dam. Let me stress on the term short pipe. It's a very short pipe used to carry water through a highway. Highway is being used synonymously for a road. It can be either through an embankment or through a dam. This is the definition for a pipe culvert. Before we take off for the preparation of a detailed estimate, we have to identify the various parts of a pipe culvert, because unless you know the various parts of the construction, in this particular case it is the pipe culvert, we will not be able to make the estimate. So here are the parts of a pipe culvert. Yes, the first one is obviously a pipe. In order to brace the pipe on either sides, that means to hold the pipe in position, we need head walls. Head walls are the walls on either sides of the pipe which hold the pipe in position. The next part is an apron. Apron is nothing but a thick blanket of stones provided both on the upstream side as well as on the downstream side. This is also called as pitching. So why do we provide an apron? An apron is provided to safeguard the earth there, both on the upstream and downstream sides, from erosion. As you all know, water as it gushes in through the mouth on the upstream side, it has a good significant velocity. And so there are chances of the bed being eroded there. In order to safeguard the bed at the mouth on the upstream side and downstream side of the pipe, an apron or a thick blanket of stones is provided both on the upstream and downstream sides. The next thing is a rough stone dry packing in revetment. I shall show you in the next slide how a revetment is. In order to support the head wall, we can either construct wing walls on both sides or we can provide slopes. In case slopes are provided, these slopes are covered with a blanket of stones, and such a blanket is called a revetment. Let me show you a model now. Here is a model of a pipe culvert. This is the pipe. This is the pipe. As I have told you, we have head walls on either sides. This is one head wall and this is the other head wall. You have 2 head walls on either sides. This side we call it as the upstream side and this side is called as the downstream sides. On the upstream side, water enters in and leaves out through the pipe at the downstream side. You can also see some walls here which are inclined, is it not? These walls are called the wing walls. Sometimes in the place of wing walls we also have slopes. In a similar way we can substitute the wing wall for a slope. That means we provide slopes here filled with granular material, and these are overlain by a thin layer of stone masonry. Just have a look at the next slide. This is the other perspective of a pipe culvert, right? You can see this is the downstream side of the pipe culvert, right? This is the head wall. This is the length of the head wall. This is the other head wall. That means we have two head walls, one on the upstream side, one on the downstream side, and these two head walls, they hold the pipe in position. This inclined wall here is called the wing wall. As I was telling you, these wing walls can be substituted for slopes. We can use the locally available granular material for making the slopes. Why do we need slopes here? These wing walls or slopes are required to support the head wall. This head wall will be supported by this wing wall or slopes. Let me show you the pipe here. This red lining shows you the pipe, right? You can also find something else around the pipe, that is called benching. Is it okay? In the previous slides I was also mentioning to you about the aprons. This is the apron. This is the apron on the downstream side. What does this apron do? It prevents the bed from getting eroded. This is a thick layer of stone masonry here. This is provided in order to safeguard the bed here from the gushing waters which are coming out of the mouth of the pipe culvert on the downstream side. A similar apron is also provided on the upstream side. Now, before we make an estimate, it is necessary for us to make a logical sequence of various activities that would be carried out in the site. So all of you must and should visit a site before you attempt to make an estimate. It is because you have to know the various activities that would take place in the site. Okay, I assume that you would be soon visiting a site. The first and foremost thing after clearance of the site is done is, what do? We make some excavations. Excavation is nothing but digging. Why do we dig? We dig to provide for the necessary foundations, and wherever some refilling is to be done, there also we go and do the excavations. So the first item would be earthwork in excavation. So what I suggest you to do is just have a logical sequence of various activities. What is to be done next as soon as excavation is done? We fill in it. We fill in using some concrete. You have heard about some PCC and so on. It's called plain cement concrete. The second step would be to fill in with the required foundation bed. That is also called as the foundation bed. The next would be construction of masonry. Wherever masonry constructions are required, we go and construct the masonry. In this particular case, the masonry wall is required in case of a head wall. If you choose to have a wing wall also of masonry, then even the wing wall has to be constructed with masonry. For this particular problem, let us choose brick masonry. What would be the next step? Yes, the next step would be plastering. Is it not? As soon as a wall is constructed, any construction preferably should be plastered so as to give it a very long life. After plastering, the head walls are ready. What is to be done next? You fix the pipe. You fix the pipe in position. Now the pipe is fixed. What next? We have to go in for the bedding or pitching of aprons both on the upstream side and downstream side. In case the wing walls are substituted for slopes, then we go in for the revetment of slopes also. This is how the activities are arranged, logically arranged. After arrangement, we now go in for the detailed estimate. Now, what is the first thing I said? Yes, here it is. Look at this slide. It is the earthwork in excavation. In order to calculate the quantities for earthwork in excavation, look at the section and plan here. We need to have both the plan and section of any construction that is to be made. This is the plan. Is it okay? Now I will explain to you part by part. This particular part is the apron which I was referring to. Apron or pitching on the upstream side. So can you get the data here from this plan? When we are making an estimate of the quantities of stone required for aprons or pitching on the upstream side, you can get the dimension from the plan here. See, this is the length of the apron, this is the width of the apron. This particular one is nothing but the head wall. As you see from the top, this is how it looks. You have a head wall on one side, the head wall is also there on the other side. Now what is this? This is the apron on the downstream side. Usually the width of the apron on the downstream side is more because the velocity of the waters are more at the exit. Here on the upstream side it is 1500, here it is 3000. Is that okay? And now what are these lines? These lines indicate the slope of the embankment. This is the slope of the embankment on the other side. Now you can see these dotted lines. These dotted lines are the pipe. They signify the pipe which is running through the body of the embankment. Here is a longitudinal section. In this particular case, you can see the head wall here. This is the longitudinal section of the head wall. This is the head wall. This is another head wall. And for study today, we are constructing the head walls in brick masonry. You can see a layer of concrete here. This is the concrete which is laid in the foundation for head wall. This is the longitudinal section of apron. Apron on the upstream side, apron on the downstream side. So I'm just presenting this figure to you in order to say that a detailed study of the plan and elevation, cross section, whatever is available is required in order to make an estimate, a detailed estimate. Is that okay? Now we move on to the first item of study. Yes, earthwork in excavation and depositing on bank in moderately hard soils. Yes, where do we have to excavate? The first thing would be under the head walls. You need to excavate under the head walls. The next excavation would be required under the pipe. Before you fix the pipe in position, you have to lay a thick layer of granular material so that the pipe is in position. Where else do you need an excavation? You need to excavate under the apron on the upstream side and the downstream side. Is that okay? Now we'll move on to the next slide. Just see this head wall. As I've told you, excavation is required under the head wall. This is a view of the head wall. This is the ground level. Any excavation is required only below the ground level, is it not? As you can see in the slide, a part of the structure is below the ground, a part of it is above the ground. In order to accommodate the structure below the ground, you have to excavate. Now for that, what do you need? You need the length of the wall. Okay, in this particular case, the length of the wall is assumed to be 6000 mm. In all the figures, the dimensions are in millimeters. Is that okay? This is the width. This is the base width of the head wall. How deep must you dig? It is 1000 mm deep. Now, is it clear that this is the length, this is the width, and this is the depth? In any calculations of while preparing a detailed estimate, you need the length, width, and depth. Generally, we dig slightly longer. This is 6000 mm, that is 6 meters. So we will just dig slightly, we'll give a tolerance on either sides. Just have 20 mm on this side, 20 mm on this side, so that the marking can be done accurately inside the pit. Now shall we see the calculations? Yes, this is how it is. How many head walls are there? One on the upstream side, one on the downstream side. So the number of walls are 2. Now, as we have seen in the previous slide, the length is 6 meters is the length, and we have added a tolerance on either side. Now this comes to 6.4 meters or 6400 millimeters. The width, as you have seen in the slide earlier, is 1400 mm. The depth is 1000 mm. So this is how we make calculations. As soon as we calculate from the plan and elevation, we need to tabulate them. Tabulate them means you have to make these postings in a tabular form so that it would be convenient for us to make calculations of the quantities. Now this is how a table looks. In any table related to estimation, you have a column. This is a serial number which accommodates the number of each item. The second column is the description of item, because we have a number of items in an estimate, like earthwork, construction of brick masonry, fixing the pipe in position, so on, plastering, and so on. So these items are described in the second column. Do you remember that in the earlier slide we have recorded the number of head walls as 2, because we have one head wall on the upstream side and the other head wall on the downstream side. The length also we have calculated as 6.4, the width as 1.4, the depth is 1. So how do you get the quantity, or in terms of volume? That is in meter cube, because for convenience all tabulations are being made in meters. As you know, L into B into H will give you the quantity. The quantity here is 17.92 cubic meters. Now where else do you need to excavate? You have made the calculation of quantity under the head walls. The next item is like this. It is excavation for pitching on the upstream side. As I have told you, this is the three-dimensional view of the apron on the upstream side. Do you remember that the width of the apron is 1500 mm? Fine. And now see here, this is the area where pitching is to be done. Pitching is nothing but laying of stones along this area. Is it okay? Now you need to make an excavation here along the apron on the upstream side. What dimensions do we require? You need the length. The length is same as that of the head wall, that is 6 meters. The width here is 1.5 meters. And how do you get the depth? The depth is also mentioned in the cross section. Is that okay? Now here we calculate. There is one apron on the upstream side. Because we are making the calculations for apron on the upstream side, the number is taken as 1. The length, as you have seen in the earlier figure, is 6 meters. The width is 1500 mm. The depth or thickness is taken as 300 mm. So do we tabulate this? Yes, here look at the tabular form. Now this is for the second item that we are doing. The first one being excavation under head walls. Now the item B is pitching on upstream side. As I have told you, there is one apron on the upstream side of length 6 meters, width is 1.5, and depth is 0.3 meters. Now again L into B into H, it comes to 2.7 cubic meters. What would be the next area where excavation is to be done? Yes, it is pitching on the downstream side. It is a similar item, just as we have done for pitching on the upstream side, we do calculations for pitching on the downstream side, and here it is. Yes, pitching on the downstream side. Tell me how many numbers are there? You have one number of apron on the downstream side. The length is same as usual, but here is a small change in width, because usually, as I have told you, the width of apron on the downstream side is slightly more. In this case, it is 3 meters or 3000 mm. What is the thickness? It is 300 mm. Now, do we tabulate them? Yes, here it is. Now we are doing the item C, earthwork in excavation and deposition on bank. That means this is a quantity where earthwork is done and excavated material is to be deposited elsewhere, right? This is item number C, where pitching for apron on the downstream side is done. Again, there is one apron on the downstream side of length 6 meters, width 3 meters and thickness 0.3, and this comes to 5.4 meter cube as usual. Now, there is one more area where excavation is required. It is under the pipe, is it not? Before you fix the pipe in position, you have to make an excavation under the pipe to a certain depth so that it is filled with granular material and the pipe doesn't move out of place. We move on to the next topic. Yes, this is for bedding under the pipe. This is the embankment through which the pipe is running. Now, in order to make an excavation under the pipe, what do you need? You need the length of the pipe, the width of excavation under the pipe which is required, and the depth to which it has to be excavated. This is the length of the pipe. Okay, as you can see here, a part of the pipe is braced or it is embedded in the head wall. A part is embedded here, a part of it is embedded here. So you have to make an excavation only in this area, only the area which is between the walls. No excavation is required for this length because this part is embedded inside the wall. So when we make the length calculation, take the total length and subtract the length of pipe which is embedded inside the head wall. This is how it goes. Just note, the top width of the embankment is 11,000 mm, the depth of the embankment is 2,800 mm, the slope of the embankment is 2 in 1. That means 2 horizontal to 1 vertical. Now shall we calculate the length of the pipe? Yes. How do we calculate the length? It is 11,000. You need this length, is it not? You need the bottom length here. How do you get that? To this 11,000, add this part. Fine. This part, this horizontal part on one side, this horizontal part on the upstream side also. Because the slope is given and the depth is also given, from this triangle, you calculate the base width. You have a triangle here, is it not? One on the upstream side, one on the downstream side. You calculate the length from the triangle because the depth is given and also the slope is given. That comes to 2 into 2,800. 2,800 is the depth, 2 is the slope, 2 horizontal to 1 vertical. Why did I multiply it with 2? Because this is the width here on the downstream side, this is the width here on the upstream side. So I have to add twice the base width to 11,000 in order to get the total length. This has come to 22,200 millimeters or 22.2 meters. As I have told you, the next step would be to make a deduction of the length of the pipe which is embedded in the head wall. Shall we make a deduction now? Now have a look at this slide. You see here, you just make a neat sketch of the head wall. This is the top of the pipe. Okay, this is the top of the pipe, this is the bottom of the pipe. This length is to be deducted on either sides. Okay, this is the 600 mm is the length or depth of overburden over the pipe. 1200 is the outer diameter of the pipe. 2450 mm is the overall depth of the head wall. So after laying of concrete, the base width would be 1100 mm. So what do I do now? From the total length of the pipe, let me call this as AB. Let me call this AB. Let us calculate the length of AB and subtract on either side from the total length of the pipe. So let me calculate AB for you. How do we get AB now? AB is, you take this as a rectangular piece, right? Because this is 400, this will also be 400. To this 400, you have to add the base width of this triangle. This triangle. Is it okay? How do you get the base width here? To 400, you have to add the base width of this triangle at this level. That comes as, the total is 1100. So 1100 minus 400 is 700 here at this level. So 700 into depth is 1800 divided by total depth. Depth at this level is 1800. 600 plus 1200 is 1800 divided by total depth. So the length of AB comes to 920 mm. This is a simple mathematical calculation. Just draw a neat sketch of the head wall and you get the calculation here. As I have told you, from the total length of the pipe, we have to subtract twice the length of the pipe which is embedded in the head wall. 920 is the length of the pipe which is embedded in the head wall. So twice, that means one on either side. One head wall on the upstream side, one head wall on the downstream side. Subtract twice of it. It comes to 20.36. This length of the pipe, 20.36 meters, is often used as we progress ahead with the detailed estimate. So please keep in mind that the free pipe which is between the head walls, the free length of the pipe is 20.36 meters. What do you need next? You need the width. Let us calculate. For calculation of width, you need the cross section of a pipe. As I was telling you, this is the pipe. Okay, the pipe is embedded in a thick blanket of granular material. So just look at the cross section of. Let me repeat once again for you that we use the plan, the section, that is both longitudinal section, and in this particular case we are using the cross section to get the required data. Is that okay? Now here 435 mm is the depth of granular material which is to be laid. 1650 is the width of the granular material. Now the width is 1650. I have added some tolerance here because a pit of slightly longer dimension is dug so that the marking can be accurately done. So this comes to 1950 mm. Depth is 435 mm from the picture. Now you know the length of the pipe, the width of the pipe, and the depth of you know the length of the pipe, the width of excavation which is to be done, and the thickness of granular material which is to be laid. So you have to dig a pit which is of the same thickness, that is 435 mm. Now shall we tabulate these results? Here it is. The last one is earthwork in excavation and deposition on bank in moderately hard soils. There are different types of soils, but when we make an estimate, we assume that the soil is sufficiently hard, because excavation in a hard soil will cost us slightly more. So when the estimate is slightly more, it doesn't matter for us, right? So for safety, we assume that the soil is a hard soil. So this is the last item in the excavation part. This is for bedding under the pipe. There is one pipe, so under the column of numbers you have 1. The length of the pipe, as we have calculated in the earlier slides, is 20.36 meters. The width is 1.95 and the depth is 0.435. Multiply all these number into length, into breadth, into thickness or depth. It comes to 17.27 cubic meters. So, have you observed that we have calculated 4 different areas wherein earthwork is required, is it not? This is the last one. The first item is under head walls. The second item is for apron on the upstream side. The next item was for apron on the downstream side, and now it is for bedding under the pipe. So, can we bring all these 4 items to a single place so that the total quantity of earthwork is available? Right. Now, we tabulate all these 4 things in a single sheet. Yes, this is how it goes. The same thing which we have done earlier in 4 different slides is combined here in a single tabular form. This was for head walls we have done. This was for pitching. This is for the second item was pitching for upstream side, pitching for downstream side, and for bedding under the pipe. Adding all these, it comes to 43.29 cubic meters. It means that we have to make arrangements for excavating a volume of about 43.29 cubic meters. Is that okay? Now, we move on to the next item. What would be the next thing? After excavation is complete, we have to lay down or fill in it with the required material like cement concrete. Do we move on to the next item? Yes. Yes, it is cement concrete 1 in 3 in 6 using 40 mm HBG metal under head wall. Have you seen a ratio here? Yes, 1 is the cement, 3 is the fine aggregate, 6 is the coarse aggregate, and we use 40 mm hard broken granite metal for the coarse aggregate. This is used for filling the excavation under the head wall. Rather, I can call it as a base material for foundation. Yes. Now look at this. I will show you the model again. This is the head wall. Before the construction of head wall is undertaken, we need to lay the foundation. One head wall on the upstream side, the other head wall on the downstream side. Now take care of this figure. We need to pick up the dimensions from this figure. You see, this shaded material or hatched material is the thickness of cement concrete which is to be laid under the head wall. Already an excavation 1000 mm deep is already made. Out of the 1000 mm, we fill a depth of 150 mm with PCC or cement concrete, right? And what is the length here? See, this is 1400 mm. This is the width. With the width is 1400 mm. The length is 6000 mm. The thickness of PCC is 150 mm. So from this figure, you got all the 3 dimensions. Now look at this. This is how we tabulate, because there are 2 walls on either side, one on the upstream and the second one on the downstream side. This is how we arrive at the quantity of cement concrete using 40 mm HBG metal under head wall. There are 2 walls. The length, the calculation of length I have told you in the earlier slides. 1.4 meters is the width. The thickness is or depth. It is 0.15 meters. On multiplication, 2 into 6.4 into 1.4 into 0.15, it comes to 2.688 cubic meters. Now this part is over. You have laid cement concrete under the head walls. What next? You need to lay some granular material under the pipe. Now we move on to the next item. This is compacted granular material under the pipe. let me repeat that compacted granular material is required so as to keep the pipe in position, right? Now see here, this is it is very much essential for us to make sure that the material around the pipe is compacted. Now shall we see how to obtain the dimensions? Yes, these are the head walls as we have seen. This is the pipe which is braced between the head walls. This is the depth, this is the width. Now again in a similar way we have tabulated them. How? Compacted granular material under pipe. As you can see, have you observed in the previous slide that a part of the pipe is embedded in the granular material below. So that part of the pipe has to be, that volume occupied by that part of pipe which is inside, which is fitted inside the granular material, has to be subtracted. This calculation is normal, length, breadth, thickness. All these three we have obtained from the previous slide. It comes to 14.61. Why did I deduct it? I have made this deduction because a part of the pipe is embedded in the granular material. So from 14.61 you subtract 0.063, it comes to 14.55. We need 50% more material because we compact it. So for this 14.55, add 50% of the material so that on compaction it reduces in volume to 14.55 again. Right? Now to the next item. The next item is construction of first class brickwork in cement mortar 1:5 in head walls. Right? How do you calculate it? A simple trapezium. Right? Let me show you the figure. This is the trapezium. Right? Top width is 400, base width is 1100, right? So I take the average of that. To get the average width, I have taken it as 400 plus 1100 by 2. This is the pipe in the body of the head wall which is running along. Now, this is how we tabulate it. First class brickwork in cement mortar 1:5 in head walls. You have two head walls. The length of the head wall is 6. I told you that I have taken the average of the top and base width of the embankment. This is B, and the total depth of embankment or height of embankment is 2.45. It comes to 22.03. As you have seen, through the body of the head wall there is a pipe running. So we deduct for that portion of the pipe. There are two areas where the pipe is embedded, two head walls. So 2, this is the area of pipe, pi by 4 d square, right? This is the width of pipe portion, and multiplying this area 2 into area into this length or width I can call, it has come to 1.69 cubic meters. After deductions, the net area or the area of first class brickwork which is required is 20.34 cubic meters. Any construction which is made has to be plastered. So obviously the next item would be plastering. Yes, here we move on. Plastering with cement mortar 1:4 on upstream, downstream, top and batter faces of body wall over ground level. Plastering is required only over the ground level, on the body wall, on all the faces, over ground level. Let us see the figure for the purpose of calculation. This is how it is. So length, as you know, is 6000 mm. How do I calculate the total area, total depth? Let me start here. This is 1200. Okay, 1200 plus 600 is 1.8. This is 1.8. I have added altogether 1.8 plus 0.4. Okay, this is 0.4, and on the inclined face it has come to 0.63. To simplify, I have just added all round. Okay, plastering is nothing but it is in square meters, multiplication of length into width or height, whatever it is. So 1.8 plus 0.4 plus 0.63, it has come to 2.83. Just multiply the length 6 meters with 2.83, you get the area of plastering which is required. Here we go with the tabulations. Plastering with cement mortar on upstream side, downstream side, top face, bottom face of body wall, over ground level. This is what we have done. On adding all the faces, we got the dimension as 2.83. This is the length. There are 2 head walls, so multiply it with 2. It has come to 2 into 6 into 2.83. It has come to 33.96. As you can see, the pipe is embedded in the head wall, is it not? So we make deductions for pipe vents. Okay. How many vents are there? There are, for every head wall you have 2 faces, right? So I have taken 2 areas on each wall, 2 vents on each wall, right? So there are 2 head walls. So 2 into 2, it comes to 4. 2 for one head wall, 2 for the other head wall. This is the area of the pipe. Right? 1.2 is the outer diameter of the pipe. So pi by 4, pi d square, total area, right? This comes to 4 into this area will give you 18.10. I have made the deductions. It has come to 15.86 cubic meters. Now the next item would be to fix the pipe in position. So this is an item where the RCC pipe of a required length has to be supplied and fixed in position. That is the next item. For this you need to calculate the length. I am sure that you remember that we have already calculated the length of the pipe in the earlier items, right? We directly tabulate that. Just see the model and we go for tabulation. This is the length of the pipe braced between both the walls. So this length of the pipe we have already calculated. Now here, this is how we tabulate it. There is one pipe, the length is already calculated. 1 into 20.36, it comes to 20.36 again. There is only one item left in the detailed estimate of a pipe culvert, which you are eagerly waiting for. That is nothing but pitching with stones on upstream side, downstream side, and for the slopes. In this particular problem, you have seen the wing walls, is it not? I have substituted the wing walls for slopes. Is that okay? Calculation of the quantity required in a wing wall is very easy. Length, width into height. So I have not considered a wing wall in this particular case. I have considered a slope on all the 4 sides, one slope on each side. Is that okay? So the next item, we will calculate the quantity of stones which are required for revetment of side slopes for the upstream apron and downstream apron. Shall we move on? Yes, it is rough stone masonry dry packing. The first item, as I have told you, for 300 mm thick revetment for side slopes. Why do we need a revetment? We need a revetment as a protecting layer of blanket of stones so that the slopes do not slide away. Okay? To protect them, we need a revetment. In this particular problem, I have taken the thickness of the revetment as 300 mm. Right? This figure I have picked up to show how a slope is. These are nothing but the vents. Through these vents, we can also provide pipes. This slope you can see here, is it not? This is the slope filled with some granular material, and this is overlain or packed with a thick layer of stones. That is what we call it as revetment. Such slopes are there on all the 4 sides. One here, 2, and 2 similarly on the other side also. So there are in all 4 slopes on all the 4 sides. For the purpose of calculation, these slopes for calculation of quantity, we assume that they are 1/4 that of a cone. You just cut a cone into 4 parts. Each corner would make 1/4 of a cone. Okay, this is how it is. See here, there are 4 cones, 4 quarters of cone. So when we add all these, it comes to a single cone. Okay, this is how it is. So can you calculate the quantity of a cone or volume of a cone? This is the blanket, these 2 lines. Between these 2 lines, the blanket is there, that is called as rivetment. The thickness of the rivetment is 300 mm. So how do you get the volume directly? 1/3 pi r square h is the formula. 1/3 pi r square h. From the outer volume, deduct the inner volume. So you get the thick layer of rivetment here. You get the volume of rivetment. Is that okay? 1/3 pi r square h. Outer calculation you do it with 2.3 meters, and the inner volume you get by calculating with 2 meters. Subtract both and you get it as 1.892 cubic meters. The next would be for rough stone packing for upstream bed pitching, right? This is the bed pitching. You can also call it as apron. Shall we get the dimensions from the figure? Yes, see here. See, this is the width, the length of the apron. Okay, and now this is the width of the apron, this is the length. Okay, 2300, this green line I am showing it to you, it represents the slope. Okay, we have assumed a quarter cone, is it not? This area is that area which is occupied by the cone. And now we calculate this middle area which is left out after laying the side slopes is the area for rough stone packing on the upstream side. That is what I have done. 1.4 is the length on this side, right? 4 meters is the length on this side. So I have assumed a trapezium here. This is 1.4, this is 4. So the average has come to 2.7 into thickness is 0.3. So this has come to 0.81 cubic meters, right? The next and the last item would be rough stone packing for downstream bed pitching. It is a similar item as in the previous case of upstream bed pitching. You have seen here, these are the students making a tour to a site where a culvert is there. You can see all of them standing on the apron here. Okay, I have just picked it up for you to see the real site image. Okay, this is the apron. The place where they are all standing is the apron. Just multiply with the dimensions and you get the quantity of bed pitching that is to be done on the downstream side also. And let us see the figure now in a similar way. Okay, the length is 6000. Width here is slightly more. If you can observe on the downstream side, it is slightly more. Okay, the depth or thickness we have assumed it to be 300 mm again, and this is how we tabulate. In this particular case, I have taken LBH, I got the quantity, right? From this I have deducted the side slopes. In the previous case, I have just taken the middle trapezium part for calculation. Here I have taken the entire rectangular area and subtracted the area of the side slopes. So in this session of detailed estimate of pipe culvert, you have studied or learnt the way or method of picking up the dimensions from plan, sectional elevation, cross section and other things, picking up the dimensions and calculating or making detailed calculation for the purpose of a detailed estimate. This is how we tabulate them also. This finishes the design of detailed estimate of a pipe culvert.
In today's class, detailed estimation of RCC slab culvert and RCC overhead tank is discussed. Let us first start